start from the foundation by introducing the kids to learn how to write the numerals, teach them how to write the alphabets, and then they graduate. Gradually, you start introducing them to a formal classroom environment. I say, sit down, okay? When I say sit down, you sit down. When I say stand up, you stand up. And then they start to recognize shapes, and then patterns in pictures. You try to help them to measure, okay? This goes a long way to assist the student to see what operates. And so therefore, you build a child-teacher relationship. Because in everything we do in life, relationship is crucial. The young mind believes so much in his teacher that at this level, the teacher will teach him also how to put on the computer, how to operate the computer at this age. And I felt thrilled when I saw the report sheet of a grandchild. And I said, wow, so they teach them ICT at that age, less than 4 years. And what happens at this point? The teacher, in introducing them to mathematics, he said, look, suppose we have 6 apples, and then I take away 2 apples, so you are introducing him or her to minus sign. So suppose I take away 2 apples, or shall I take away 2 apples? She will take away 2 apples. If you take 2 from 6, you are left with 4. He or she feels excited. It's learning mathematics, okay? Because he needs it, she needs it, he needs it. But if you now go a little bit further, and you give the child 3 apples, and you say, we want to take away 4 apples, then you get confused. Because it's not yet able to observe minus sign. It's still operating at the natural number, the counting numbers. So that is the level at which he or she is operating. So when you say, I have 2 apples, take away 3 apples, we can't see it. Take 1, 2, we don't have to up to 3, so it's impossible. And it is accepted as impossible at that level. But the moment the child graduates and come to the primary school, you now have to introduce the child to integers. So we know about the positive integers and know about the negative integers, and then he understands the concept of subtraction to a higher level. And this is a new experience for the pupil at that level. And so you need not go back to teaching the fundamentals again. You build on it. So let him know the summation sign, and then you let him know the subtraction. And at that level, he has to know the multiplication. So gradual development of educational lifestyle, so that they will be able to understand what operates. So the child is excited, and like I wrote here, it is supposed to be the child's launching period to better understanding of mathematics. So now we come to learning this educational development at the junior secondary and the senior secondary. The child is taught some mathematical equations. Equation in 1 variable, equation in 2 variables, and then he learns how to solve simultaneous equations. Then you teach him how to solve the quadratic equation, and then you tell him, yeah, there's one formula we call the almighty formula if factorization does not work, and then gradual process, and then you teach differentiation. If you are doing further math, do you call it further math or additional math? Further mathematics. And then you go to integration. So anywhere I go to give a talk, I encourage the students, you must do further mathematics if you want to come to the university, because you will have been introduced to the concept early enough. And so we try to build on abstraction. We have to teach the child abstraction, give some word problems that will enlighten him or her to move into greater mathematics. And then now come to the great university. Ideas are made more concrete. While in the secondary school, you tell the student, what is the square root of minus 2? A secondary school student cannot comprehend it. He will tell you it is impossible. Because that is the level, that's the educational development. He doesn't know what it means. But in the university, We introduce him or her to the fact that if you have the square root of a negative number, then you have complex number. So you are going from the real number system, you are going to the complex number system. And then you broaden this horizon, and then it has better understanding that all the problems I met when I was in secondary school and I could not tackle, I cannot go back and tackle them. So that's the development. And there again, we teach the student how to ensure that you minimize the error. So we teach the concept of minimum error in everything you do. As much as possible, you want to minimize the error. So in the university also, we try to let them to contribute to the society through knowledge acquisition and also pursuit of research up to the highest level. And I thank God I was privileged to have the opportunity to have my education up to the highest level. So I can interact and also learn more. Now, why learn mathematics? One beautiful thing about mathematics as a science subject is that it does not require very expensive equipment. All I need is my biro, my pen, probably a small machine to operate. If I have opportunity to have a computer, fantastic. If not, have a calculator, I can do some work and I can get some results. And in the university, all I need is my laptop. Okay? I don't need to have hundreds of assistants to support me to get the thing going. But mathematics is such that you can do it individually and able to get a result. Okay? But more often, you are alone to do the problem, to attack the problem. It's only when you cannot go, you need a collaborator. And I'm happy to announce to us that I have a young collaborator in this university. And I'm privileged to inform us that Kule Salau is my young collaborator in this university. Okay, I'm trying to groom him. I'm also trying to encourage him and to be able to be like me. I want to impart on him. Okay? So you get collaborators, you work together. If you succeed, fantastic. If you fail, good. This morning he told me that one of our public papers sent to one of the international journals in Elsevier was accepted. I said, well, that's good news. Okay, I was happy for him. Okay, I don't need it for promotion, but he needs it. Okay, thank you. So we have why learn mathematics? The framework of mathematical modeling. That's where I'm going, and that's what we are discussing throughout today, mathematical modeling. And that's my area of specialization. In applied mathematics, it's synonymous to solving word problems in secondary schools. You are introduced to latitude and longitude. And I'm teaching my current students now in the university. I said, what did we assume? We did projectile. You launch a projectile, it goes straight and hit the ground. They said, yes. So what happens? When you launch it, either throw it up to be monetarily at rest, and then it will come down. If you launch it at an angle, it will go, and it will go horizontally and hit the ground. I said, that is assumption for secondary school. Now you are in the university. You have to recognize one important thing. That is, we have assumed that the earth is stationary. I want to ask this audience, is the earth stationary? It's not stationary. It's revolving around the sun. It is also rotating on its axis. But you have assumed all these things are not important because educational development. You have to assume some things for that level and then release their mind and make them know that no, we have relaxed this, so we need to remove it and use it again. So I now taught them, I remind them of what they were taught in secondary school, and we progressed. And they were all excited. They said, so, but when we were taught latitude and longitude, we didn't know. We said, we use it for navigation. So if you launch a projectile at an angle, it does not go horizontally and hit the ground because the earth is rotating. You will have missed your target. And they say, yeah. So if you want to send a missile from Nigeria to Cameroon, you must take into cognizance the fact that the earth rotates. Okay? So that is everyday living. So the realistic condition we are talking about is that you have to change conditions depending on the level of development. Otherwise, people will get confused. People will get lost. And you want them to understand what you are passing across. Also, at its foundation lies all the physical, foundation lies a physical problem. You must have a problem motivated by nature, like the one I've just spoken about, latitude and longitude, doing the projectile. Yes, under certain conditions. The first condition was that the earth is stationary, and now I'm telling you the earth is not stationary, the earth is rotating, so you are making assumptions. This physical description of the problem are then converted to mathematical arguments. You now have to solve it using mathematical skills, using the tools of mathematics that you have. So you cast that physical problem, and I'm going to show you an example at the level of the secondary school, and then let you see better what we have in mind. And then you have to solve the equation. Probably it's a differential equation. Probably it's an algebraic equation. You see, and then you solve. And we call this model equations. And once this equation is solved, your aim is to validate. You have to be sure that what you are getting makes sense, and validate it probably with experimental or against any related experiment, and your aim is to interpret the result. So very simple. You model, you have a physical problem, you make assumptions, you cast it in mathematical equations, you solve the equations, you interpret the equation. Mathematical modeling. Okay? So, this is what I'm saying. Model in applied mathematics entails a real world problem. You have a problem in the world you want to solve. Okay? This problem is not precisely defined, it's difficult, it's vague. So there's so many things happening. You want to model the weather. It's very complicated. You have to have conservation of mass, conservation of momentum, conservation of energy. It's very complex, three-dimensional. And then you say, well, what do? We make simplifying assumptions to make the problem simple enough to attack, to have a first approximation, and then proceed to improve on it. So when you do that, you have built a model. And that mathematical model needs to be solved using your mathematical tools, either analytically, numerically, functionally, solve it, and then you need to interpret your result so that the engineer will be able to appreciate what you are doing. Now, if that is accepted, let's take a real-life problem. Ways mathematics can save the world. I decided to bring up this example. It's a physical problem motivated by nature, and it's very simple. The first case is titled greatest possible or maximum, or what we call optimization. And thank God for Mr. Vice Chancellor, he spoke on turning point, derivative. He was saying this thing, So we want to find, we have equal squares, must be cut out, okay, of a square. You can see here, we have a square, must be cut out of the corners of a square piece of cardboard, 18 centimeter by 18 centimeter, in order to fold the cardboard along the dashed line, as shown in this figure 1, and make a box of the greatest capacity possible. Very simple problem. We have a square. We want to cut away from the edges of the square. Some square, I don't know how I'm going to do it, but this is a real life problem, and I want to fold it to make a cardboard. Many of you, when you go to provision shops, you will see cardboards. Am I right? So you see cardboards, but how did they come about it? How are they able to maximize it? Or if I want to minimize it, how can I do it? It's a real life problem, and we need to find a way by which we can accomplish that. So this is the problem we have. The question is, how do we approach this problem? How do we solve this model? So what I did was to look at scenarios. So I have 3 scenarios. And the first one is to look at it from this perspective. I construction of boxes using iron sheets. Okay? I have iron sheets, 17 centimeters by 17 centimeters. I've decided to cut squares of 1 centimeter by 1 centimeter. I fold it. I have the box. I decided to say, okay, it's all right. That's one. I put it aside. I decided to cut out of the corner squares of 1.5 centimeter by 1.5 centimeter. I construct the box. I can continue 2 centimeters by 2 centimeters. I can do that, just measurement. Don't forget, it's just measurement. I remove it from the edges of the square. I fold it, then I have a box. I can continue this sequel. And at the end of the day, how can I be sure which of these boxes I've created will contain the largest volume of liquid or water? So the next step will be for me to pour full buckets of water until each box is full to the brim. That's a simple way to do it. Okay, I tried that. Okay, how many buckets have I used for this first one? I'll write it down. How many buckets have I used for this? I'll write it down. Fantastic. I will see the one that will contain, I will identify the box that will contain the largest amount of water by knowing how many buckets of water filled which one. And I've solved my problem. That's the way to solve my problem. That's a real life, but this is very costly. It's very costly because I'm going to buy a lot of materials. I cannot use cardboard. If I pour water into cardboard, it will collapse. So I need to use iron sheets. It's going to be a lot of, how do I dispose all these materials after picking the one with the highest, the box with the highest volume? How do I discuss this thing? How do I dispose them? It's a problem. Okay? I leave it. Let me try another method. Okay? Another scenario. Okay, this is the box, 18 centimeter by 18 centimeter. I remove the square from it. This is the square. Look at the square here. There's a square here. There's another square here. So I represent it by X. At least I know a little bit of mathematics. Okay? So I use X to represent it. Every time you see X, you know a mathematician is talking. Okay? So if I remove X from, if I remove X, what do we have? We have removed X from this side. This pointer is not giving me the light. Okay, I remove X from below, and then I remove X from here also. Okay. Oh, okay, probably I should use this so that it will be clearer. Okay. Is this what is happening? Operator, it's like coming and going. Okay, look at the base. I remove X from the left, I remove X from the right, so I'm left with 18 minus 2X. Because the length must be 18, so I add everything together, I have 18. This is a simple approach to the problem, very good, and it's really working. So what do I do next? It's very simple for me. I've decided to look at it from another perspective. So, what is the volume of my material? The volume is length times breadth times height. There's no problem. So I can generate the equation. F of x is 18 minus 2x times 18 minus 2x multiplied by x. That gives me the volume of this box that I'm looking for. Okay? If that is agreed upon, then I can use the method of trial and error. I have a function, f of x. And it's a polynomial of degree 3. And I can now substitute f of 1. I'll get the volume to be 256 centimeter cubed. I try again. I see here. Then I have, if I put x is 2, I have 392 centimeters. You can see the number is increasing. Then I tried f of 3. Then I have 432 centimeters. Then I go to x is 4. Then I have 400 centimeters. Okay. I think there must be a turning point, like the Vice Chancellor told us earlier. But yes, the thing has changed. It has changed from increasing, it has now been decreasing. So what is my deduction here? The required value of x, which is the square I'm going to remove, must be in the neighborhood of x equals 3. Why am I using that conclusion? I'm using this conclusion because I know that so far so good, I have considered natural numbers. But apart from natural numbers, we have fractions. Am I here? Are you hearing me? Are you understanding what I'm saying? We have fractions. I've not considered fractions. Not only do we talk about fractions, we talk about irrational numbers. Talk about square root of 2. It's an irrational number. And okay, we have so many numbers. So I've not been able to try all the possible numbers. So, but I know that there's something in that neighborhood of 3 telling me that the maximum volume is in that neighborhood. So I take it that's the best mathematics I can do using this approach. But no problem, we move ahead. I look at the third scenario. You see the same problem, the same volume, but this time I've decided to open up the brackets. Okay, we have 18 minus 2x all squared. So I open the brackets. This is what I have. I have this simple equation. It's a polynomial of degree 3. Okay, so my aim now is to solve this equation using another technique, probably more advanced than what I have here. So what do I have? I differentiate, just like our Vice Chancellor just mentioned. If I integrate, I have equation star. Okay, I can factor out some terms as I did in the equation below, but at the turning point, it has been taught in class, to those who are in SS class, that at the turning point, the derivative must be 0. So if the derivative is 0, then I can equate the equation to be 0. Now I have a polynomial of degree 2, a quadratic equation. There are 2 ways by which I can solve a quadratic equation. Factorization. And if it's not factorizable, I use my almighty formula. Okay, I'm still within the context of secondary school. So I can do that. And if I do that, I factorize. Very simple factorization. We have the factorization. And so therefore I can get the value of my x to be precisely 3 as well as 9. The question now is, which of the 2 answers will give me the optimal box that I desire? It can be 3, it can be 9, but you need to investigate further using some mathematical tools. So I go further. So I have to investigate the turning point. Is that turning point a maximum or a minimum? So I carry out the second derivative. So you see how important it is for you to do further mathematics. To solve a real-life problem, you must be involved in further mathematics. And then I investigate. Suppose x is 3. I substitute it into the equation will be less than 0. You can see that it's physical. If I take the other value, I take x is 9, it's going to be greater than 0. And the concept of the turning point says that if the second derivative evaluated at the point is less than 0, it gives you the optimal. It's the maximum. But if it is greater than 0, it gives you the least. That means if I want to construct a box that we have the least volume, I will take my x to be 9. I take a square of 9 by 9 away from the square 18 by 18, and then I will get a box. And this is mathematics. This is the beauty of mathematics, making life much easier for us as compared to the 2 earlier approaches I've given. Let's appreciate mathematics by clapping and saying, yes, mathematics is making life much better for us. Look at the simple concept, look at the simple scenario. So what is my conclusion? The size of the cutout square must be 3 centimeters, precisely. The other time, I wasn't sure, because I've not investigated so many other fractional numbers or irrational numbers, so I'm not too sure. But I know it's something around 3, but I need to be sure. So hence, the volume is 432, just like we had earlier. So this is more precise, more concise, it's flawless, and so therefore I concluded that consequently, built into mathematics is a mechanism that is flawless. It makes life much easier for you once you follow the procedure and you do it as it should be done. Fantastic, you have something to report back home. Mathematics is a true masterpiece. Look at the way the second scenario used a little bit of mathematics. That's the level of his mathematics. He could use trial and error to approach it. At least he knows the volume of a box. So he wrote it. He didn't spend so much, but he has some knowledge of math, but not as advanced as somebody who did further mathematics that can differentiate and integrate. Mathematics approach is mind-blowing. Because when you get this problem solved, you yourself, your mind will be at peace. I say, yes, this thing has really worked out. So, okay, I'll now look further. Deduction from solving mathematical models. I've made it clear to us that you cannot trivialize the place of mathematical model problem solving for the betterment of humanity. I showed to you that if you use the first approach, you are going to spend so much resources, you are going to spend so much time, you are going to spend so much energy to ensure that you find out which of the boxes will be the largest. And the second approach was more of trial and error. We are not sure. Just saying that the solution should be around 3. It's not still not the best. But the third scenario gives us the necessary thing we needed. The truth has been revealed to this audience to have hands-on experience of mathematical tools to better our lives. You need, even if you are in engineering, you need mathematics. You cannot shy away from it. You need to have better knowledge. To encourage students to persevere and learn more applied mathematics so as not to feel like the acquired knowledge is wasted. Look at the woman in the market. I remember, okay, you go to a woman selling a provision, madam, and you say you want to buy a dozen of biscuits. And how much is one biscuit? He says 20 naira. She has to multiply 2 times 12 to be able to know how much you will pay. So you need the mathematics no matter what. And if your mathematics is poor, then that woman will run short. Because each time she's quoting the amount you will pay, she's short-paying herself. At the end, the provision shop will pack up. You need it. There is no way for you to keep the stock that you have in the store. You need to count. So you cannot shy away from the counting system. You need it. So you and I need to take this into cognizance. You can also be assured that it is an opportunity to train leaders who can train others. And that's why I'm so happy that most of the teachers are here to listen to this talk and to take something new. In the book of 2 Timothy chapter 2, verse 2, it says, teach these truths to trustworthy people. I want you to clap for yourself because you are trustworthy. That's why you are here today. Yes. Who will pass them on to others? We need to pass it on. We cannot leave it on the shelf. We need to pass it on to others. The significant message is to encourage young minds to persist in studying mathematics up to the university level. Why am I saying this for the young ones to learn it to the university level? Is that suppose I modify this problem and I say, instead of having a square 18 centimeter by 18 centimeter, we have a rectangle. Okay? Suppose we have a rectangle 18 centimeter by 16 centimeters. This third scenario will provide you the answer for the highest box you can achieve. You will get it. Using this technique, you don't need to run so much away. However, if I change the condition, and I said, I have a square, just like this problem we had, and now I want to remove a rectangle from the corners of the square. The problem has changed. Now, we no longer have one unknown, but we have 2 unknowns. Because I don't know, I have a rectangle, so I must have the length, must be different from the breadth. So I need 2 unknowns. This method that I used in this class has failed. We need to modify it. And when you're in the university setup, we use what we call Lagrange's multiplier. And many of these young minds don't know what is Lagrange's multiplier. So you need to go to the university to learn that new technique so that you can better this world for us. And so I want you to see that mathematics skill, acquiring it is important, and it doesn't end. I'm just 63, almost 63. I'm still learning mathematics. I'm still doing mathematics. But probably until I go to the grave, I'll be doing mathematics, learning new things. So it doesn't end. So I decided to give this quote so that we have something to take home. It says, neglect of mathematics works injury to all knowledge, since he who is ignorant of it cannot know the other sciences or the things of the world. So we are seeing that mathematics is helping us to have a better world. You cannot neglect mathematics. You cannot say, I don't need mathematics. It's just a waste of time. I'm going to do accounting. I don't need mathematics. Who told you? When you come to accounting in the university, you will do binomial expansion. Whether you like it or not, you will do differentiation. You will do integration. So what are you saying? I'm only in art subject, so I don't need mathematics. Why has the federal government made mathematics compulsory at the secondary school for all students? It's because it is the foundation of all the sciences. Let's clap for the mathematicians in the house. Let's clap for the mathematicians in the house. So, let's look at other areas in which optimization plays a crucial role for betterment of the world. I arrived at Omu-Aran yesterday, and I slept around 12 midnight, and I was hearing the wind blowing profusely, and I was hearing the sound. I say, wow, I wish we can harness this wind and convert it to energy, and Nigeria will not suffer from power failure. And that is why I brought that up. Optimizing the layout of wind turbines enables us to harvest more energy. Why will there be power failure when the wind is blowing fervently? We need it to turn the turbines that we have here. We need the wind, and the wind is very prominent around this neighborhood. As I was coming yesterday, I saw a school. Almost all the roofs were blown off. I didn't know what was happening. But now I know that we can use our mathematical knowledge to make the wind useful for us in this community. Secondly, we all see the computer day by day is changing. I remember when I got to the university in 1979, we were using a mainframe. Only one computer in the whole of Obafemi University. And not only that, we had to use punch cards. Okay? We have to use punch cards to run computers. But today now, we have laptops, which is helping us to, computer performance can also reduce the energy demand. So it's conserving more energy. The batteries last longer. The new computer I'm using now, the battery can last for 12, 14 hours continuously. So you need to do some mathematical modeling to improve on the performance. Also, this is the last area which I'm going to round off for today. We'll talk about predictions. Okay, apart from optimization, which I've mentioned, another factor tool that we use is predictive analysis. We predict. And for prediction can be defined as the act of forecasting what will happen in the future, and it goes back as far as human race. For example, if it is cloudy, we have that mindset that it's going to rain. Am I right? It's a prediction. You are predicting. Actually, it may only drizzle. And in fact, it may not even rain. But it's a prediction. And the prediction is based only on the physical. But when you have the database, you collect data, you store the data, you analyze the data, you can predict better. And that's where mathematics comes into play. Because it's not mere looking at it, it's cloudy, it will rain. It's not sufficient. You need to study, collect the data, and that is why I wrote it here. So we need to use some little bit of statistics, use some modeling, and then elevating to prediction of what is happening every day in our surrounding. So let's look at types of predictions. We talk about accurate weather forecasts. It goes a long way. If we can know when it will rain and when it will not rain, it will be a long way to help in the agricultural aspect. It will help us in so many areas of endeavor. Business people too will be encouraged. I know I don't need to go out at this time because it has been predicted scientifically that it's going to rain. So why do I want to risk my life? So we need to ensure that we do weather prediction. And this is based on conservation of mass, conservation of momentum, conservation of energy. We have said it times without number to young minds. Energy cannot be destroyed. It can only be converted from one form to the other. So we have to bring in all the laws. If a body is stationary, it will remain in that position, except there is an impressed force on it. Otherwise, it will remain at that same spot. These are laws of nature. You need to bring these things in, and you model these things mathematically. Newton's law says that force must be equal to the mass times acceleration. So we need to know the acceleration. So we bring these things in. So mathematicians play an important role in this process, working with a set of equations that describe the atmosphere. Considering temperature, like I said earlier, we look at the pressure, we look at humidity, we look at the radiation of the sun, because the sun is also assisting us in this issue. And then we solve the complicated equations. I cannot display such equations that will scare you away. And that's why the higher you go, the cooler it becomes. Because you know the equations, you change the conditions, and you can solve the problem mathematically and interpret so that people can understand. Businesses will also progress. People who are involved in agriculture will also be warned about drought coming. There's going to be drought. This year, it's not going to rain early, and so farmers prepare. Prediction. It's mathematics. It will better our world. It will make things much better for us. Instead of farmers taking the risk. If a farmer should go and plant when there's going to be drought, everything will perish in the ground. He's going to lose a lot of money. Who's going to compensate the farmer? So we don't want that. So we need to put all these things into place. So mathematics try to predict. Mathematics try to predict who might be at risk so they can prepare for the future. So we go further to data collection. We have said that this prediction entails getting data and storing data. If you have a small storage, after a while it will get damaged and you lose your data. If you have a computer, you use it for 4 or 5 years, it will develop some faults. If you are not careful, you lose all the data. So it becomes an issue. Not only are you trying to store the data, the question is, we have the issue of big data coming into play. Okay? We have the issue of big data coming into play. So, attendant problem to mathematical records, because we are keeping data, is storage, leading to the notion of big data. That's the order of research today. If you want to do your PhD, that's an area that is selling like hot cake. It's big data. How do we store? How do we mathematically optimize, maximize, such that we can keep our data safe from destruction? So, I come to the conclusion. The conclusion is the national problem that we have today. The issue of grazing, the issue of farmers. It has become pandemic in the whole country. Why? Because we don't have a way to keep track of the herdsmen coming into a particular region. We don't have information about where the farmers are located. So we need to answer this question. How can open grazing of cattle and farmers be modeled mathematically in order to put an end to herdsmen crisis in Nigeria? So all of us are here to propound a solution to it, because that's why we came together. We want to make mathematics a better world for us in Nigeria. This is our own problem. So, but let me give some highlights on how we can go about this. Now, look at herdsmen. It's migrating from one location to the other. We don't know what we are going to do. There's a farmer there. He's also tilling the ground, taking care of his crop. So how do we ensure that the two of them are not clashing? The man grazing is looking for greener pasture. And he gets to a place, the man has just cultivated the land, the place is green. So the cows go there and they eat the crop. And the man is crying. Okay? So I decided to look at this problem because that is why we are here. And then we can take that home. So I said the first step in the right direction is to keep records of influx of herdsmen to a specific state by registration, coupled with programmed wristwatch. You should give them a wristwatch, which we call radio frequency identification. So we know how the grace man is moving from one location to the other. We need to identify that so we can have an idea of the path this man is taking. Okay? To record while using geographic information system, GIS. Okay, that identifier is used. We can communicate with him, he can communicate with us. So we need to know. If you don't register him or her, how do you know the fellow is in your state? You don't have the information. Okay? And then this helps us to keep the itinerary and the location of cattle breeders, which will be recorded and stored over a period of time. If I don't have the data and I model it mathematically, I cannot validate. That's what we call mathematical modeling. I must validate. So once I have the data over a period of time, I'll check. And then I'll be able to know that this thing will work for us. Okay? So weather forecasting also can enhance the grazing and prevent tragic event of flooding for the herdsmen. Okay? Secondly, we need to use the GIS to know the location of the farmers, the land use. I'm so excited. You know, recently, in Oyo State, I have a small house there. The government has sent land use revenue. I said I must be paying for putting my land there. I said, it means you have captured me. You have captured my house. Okay, if not, you don't know that I have a land here. And they put my number, they put my name, they put my phone number. I was said, well, these things are easy to do. You can see the governor, Governor Makinde, had gone a step further. He wants to know. So we need to know where the farmers are cultivating. We need to have the mark, and we can use GIS to locate that. You can go up, you can take the plane and go up and get the location. You don't need to go there physically even. Okay? So we need that. And then we can now start using our mathematical model. I said, but on the mathematical side, there will be sufficient interest in its modeling, computation, so that one can understand the physical movement of the herdsmen in the state better, in the hope of optimizing their grazing and minimizing friction with farmers. That's all I've said today. Optimizing, minimizing, differentiating. Okay? It's just the same area. But however, we need more of cybernetics to be able to, cybernetics has to do with some little bit of management to be able to come around this issue. So, I want to thank you for giving me this opportunity to talk to you on what I have for you today. I believe that the herdsman example is a concluding aspect for each one of us. However, before I drop the mic, I wish to put on record that I was at the Vice Chancellor's office this morning in the company of the HOD as well as the Dean, okay, on a courtesy call. And after my brief interaction with the Dean as well as the HOD, I decided to show my interest to institute a course prize in Landmark University to be awarded during convocation to the best student in differential equation. Thank you. God bless you.
I don't understand the way you are clapping. I don't understand. An award has just been instituted in favor of the best students in differential mathematics in Landmark University, and that will happen every convocation. Students, can you join me? Put your hands together again. And then if you didn't get excited at any point in the lecture, then I think I would just wonder if you are a Nigerian or if you know the things that are facing Nigeria at the moment. How many of you are happy about the solution proposed to bring an end to the farmer herdsmen crisis in Nigeria? The RFID solution. Would you put your hands together once again and say, thank you, sir, for bringing that heart-seated lecture. Thank you very much, sir. We are very grateful. Right now, before we go into the next item on the program, we want to entertain questions. You had Prof. Speaking, and some questions were evolving in your heart. Would you like to ask such questions? If you have such, please raise your hand. Anyone with a question? My friends from the colleges here, from various schools, you are free to ask. Anybody? Okay. All right. If you are not asking, I think the simple meaning is that the lecture is so clear and the message got home. So one more time, let's put our hands together for the facilitator. All right. Before we proceed to the award of prizes to the students who did the best, as will be presented by the registrar Landmark University, today you're going to see what they call virtual presentation of gifts. You know, if you have not seen it before, get ready to see one virtual presentation of gifts and awards. All right. Before then, please, the consul will please show us a presentation that has been packaged by some of our students from mathematics program for our enjoyment, information, and education. Please, let's put our hands together for those who put the video together. Please put your hands together.
When some people hear the word mathematics, they hear difficulty, they seem scared, they lose interest, they are bored. So what is mathematics? How does it better the world? My name is Agbana Geoluwatimishi, and I'm a mathematics student of Landmark University. Studying mathematics has played a big role in helping me to combine problem solving and creative thinking. With the help of my other colleagues, we're going to tell you how this works to better the world. Thank you.
Good morning, everyone. My name is Paul Grace. I'm a student of Landmark University, mathematics major, 300 level. Finance and business. Every single sector in the world depends on finance for its continuous running and operations. Management of money is very essential in a typical business, even down to small corner shops and even business startups. We all love money, right? So what is a business without proper money management? Mathematics in finance and business draws probability, fractions, calculations, and whatnot, which is applicable in buying and selling, trade by barter, and even office jobs. You might think you don't have a business, so what concerns you with all this? But you know that spending and saving is also finance. So what is finance without mathematics? What is a business without finance? What is a world without business? So therefore, what is a world without mathematics? Thank you.
Hey guys, my name is Mowaninola George, and I'm a student of Landmark University, currently studying mathematics. Mathematics in fashion. Some of us watching this love clothing, shoes, styles, anything that makes us look good. Mathematics in fashion is measurement, proportions, cost and expenses, etc. In sewing, mathematics properly calculated and applied will determine the accuracy and beauty of such clothing. Your uniforms, office wears, traditional attires didn't just appear. It took serious care to produce such art. They all have a uniqueness that's just right for you. Therefore, proper knowledge of mathematics births fashion.
I study mathematics and computer science. Mathematics in medicine and surgery. We are all familiar with statements like take 2 pills daily, 2 milligrams twice a day, and all. But little do we pay attention that mathematics is involved in it all. We are all aware of the COVID-19 pandemic. Mathematics is used to determine breakthroughs in pandemic, like how to end amount of affected persons, formulation of vital tools and equipment. It includes basic math properties like calculations, counting, statistics, conversions, proportions, etc. For the betterment of the medical industry, mathematics should be a priority. Mathematics in food. Believe it or not, cooking has a lot to do with geometry. And without knowing the basics of math, you can't go far as a baker. First, before getting into the geometry, let's start with how cooking connects to mathematics. Properties like temperature, quantity, weight, ratio, shapes, fractions. They are involved in little details like 2 spoons of salt or pepper, 30 degrees Celsius, 5 milligrams of sugar, pot depth, and width. Here are some delicious meals. Yummy! Ooh. In conclusion, mathematics makes a proper meal, no cap.
Hello everyone, my name is Fibo Ikuba, a 300 level student of Landmark University, and I am studying industrial mathematics. Mathematics in agriculture. At some point in our lives, we had to grow a plant, rear an animal, or tend a farm. It seems rather digressing, but mathematics is very important to farmers like me. Mathematics is involved in measurement of soil fertility, estimating crop yield, also calculating costs and profits. Agriculturalists use numbers to grade and describe seeds, converting of units and measurements of areas, and so on. Further, we have things like plot variation of sizes and shapes. We also have conversion of the unfamiliar to the familiar. There are 43,560 square feet in an acre. In conclusion, we say that farmers, through intense planning and calculation, can predict all that they do.
Hey everyone, my name is Zion Alaka in the Department of Mathematics with Computer Science. I'm a student of Landmark University.
Games and sports. There is mathematics in puzzles, cycling, chess, basketball, football, and so on. How, you may ask? It involves intellectual thinking with concepts like projectile, timing, angle of elevation and depression, operations, research, drafting of strategies, and many more. Mathematics gives you a better chance at winning because you no longer play by chance but with accuracy.
Hi, my name is Tenena Jonathan and I am a mathematics student of Landmark University.
Mathematics and computer science. We are all aware that the world is going digital and technology is advancing. Without proper knowledge of mathematics and computer science, you will be left behind. Mathematics is the foundation for computer science because it involves abstract languages, algorithms, calculus, real-world model solutions, and programming. Down to the televisions, phones, wristwatches, and video games. It is the future.
Hi, it's me again. Stay tuned.
Mathematics in music.
This is important.
Sorry to interrupt your song, but this song you were listening to was produced by Ludwig van Beethoven, who became deaf but used mathematical formulas to produce such magnificent art.
You should also be familiar with Pythagoras, a famous triangle theorem guy. He contributed to develop concepts of music intervals with mathematical ratios. Basic music elements such as pitch, rhythm, tempo, form, and meter can all be related to measurement of time, frequency, which are
concepts in mathematics. Music needs mathematics.
Thank you so much. Let's put our hands together for our students in the mathematics program with different options who have put this together for us. You know, it was Paul that spoke to, I think, was it Agrippa? It's a little more word from you, you would have made me a Christian. And I feel like saying a little more videos and you would have turned me into a mathematician. So try harder next time. All right, please, let's put our hands together for them. Beautiful presentation. Right now, I'm trying to believe that the registrar, okay. Sorry, some mathematical communication needs to just be get established. You know, in this world, when you have instructions, you avoid problems. You understand? All right. Ladies and gentlemen, those of you that were in schools that were announced earlier and you were not actually in, you were not in when we were saying we are glad to be here. You have not said it here once today. Wherever you are, just wave your hand and say, I'm glad to be here. You have not said it here today. That means you came in after we said it. Can you wave your hands and say, I'm glad to be here? All right, you're welcome to Landmark University. Ladies and gentlemen, please let's make welcome Dr. Adebimpe as he handles the next assignment.
Thank you, sir. Vice Chancellor, sir. We want to announce the results of the mathematics competitions that were taken by some secondary schools in Omu-Aran. 14 schools were invited. Eventually, we had 11 schools present here. I think we can give it to Jesus. And we want to say that it is not no loser, no winner. We have a context, there must be a winner. And that means we have 22 students that partook in that examination. And we won't be able to take all the results, but we are going to mention the first 10, the best 10 students. The best 10 students, and please, there's always another time for schools. Let me start from the rear. 2 students took the 9th position, so there is no 10th position. So please, as I'm calling you, you just come here, you stay here. The 9th position, the first person I will call is Adefeyinti Motunrayo from Apostolic Faith, 57%. The other 9th position, Idowu Kayode, Omu-Aran High School, 57%. Idowu Kayode, Omu-Aran High School, 57%. The 8th position, Idowu David from Government Secondary School with 63%. Idowu David, Government Secondary School with 63%. 2 students took 6th position, so there won't be 7th position. 2 students took 6th position, so there won't be 7th position. So the first 6th position is Raji Abdulahmed, Apostolic Faith with 67%. You can do better. A round of applause for him. The other 6th position is Afolayan Ifeoluwa from Ogbo Grammar School, 67%. Then I have I don't have 5th position. I don't have 4th position. That means 3 students took 3rd position. So I'll call those 3 students out now. The 3 students, the first I will call is Adeyemi Mercy, Equa Secondary School, with 70%. Adeyemi Mercy, Equa Secondary School, with 70%. Ibitoye Ifeoluwa, Federal Government Girls College, Omu-Aran, with 70%. The third student that took 3rd position, Adenigba Fikayomi, God's Grace International School, 70%. Then I have the privilege of calling the 2nd position, Obieze Chisom, Federal Government Girls College, Omu-Aran. And please, the overall best student at the 2nd International Day of Mathematics is Dada David, Government Secondary School, with 77%. So I'm presenting the Vice Chancellor the best 10 students for this year, 2021 International Day of Mathematics. I will call the Dean, College of Pure and Applied Sciences, to present prizes to these 10 students. A round of applause for Jesus.
I want to congratulate you for being the best overall in this competition, in this 2nd celebration of International Day of Mathematics. I wish you all the best as you move forward. I believe one day you study mathematics at the university. So shall it be. Well, congratulations. So on behalf of the organizer, the Department of Physical Sciences, the houses mathematics, and under the College of Science, College of Pure and Applied Sciences, we congratulate you. We present this award to you. Congratulations. Yeah? Okay. Congratulations, Government Secondary School, Omu-Aran, 1st position. You can go. The 2nd best position in this competition is coming from Federal Government Girls College. We present this award to you. Congratulations. We hope that you study mathematics at higher level. Congratulations. God bless you. Yeah. The 3 third positions from God's Grace, 3rd position, and okay. Okay. So congratulations from God's Grace, 3rd position. Okay. Congratulations. The next 3rd position, which school is that? Federal Government Girls College. Congratulations, 3rd position. The next top position, congratulations, Equa Secondary School. So the sixth position. The sixth position, we're having 2 candidates. Congratulations. The next 6 positions, congratulations. The 7th position, Government Secondary School, congratulations. Apostolic Secondary School, congratulations. And the last but not the least, congratulations. Thank you.
Thank you, sir. We really appreciate your support. The next thing on the agenda, we have 3 best schools to be recognized. And the prize is from Dr. Olukayode Adebimpe. Is awarding prize to best 3 schools in Omu-Aran or who participated in the competition. So I will invite the HOD Physical Science to support me in presenting the gift to the best schools. Starting from the 3rd schools. So what we did in arriving at the best schools is that we sum up the performance or the total scores from 2 of those participants. That is from, let's say, from Federal Government College now, 2 students from there. We added the result together and found the average. That's what we did on how we arrived at the best schools. I think we are satisfied with that. So, based on that, the 3rd best school